Welcome to the video lecture of course code U18Pcit401 Web Programming. And I am Dr.B.Dhanalakshmi, Professor, Department of Information Technology, Bharat Institute of Higher Education and Research, going to deliver this lecture. And we are going to see today Unit 2, topic Java. First, we will see what is object-oriented programming concept. So object-oriented programming concept is a programming language concept or a model which is organized around objects rather than actions and data and rather than logic. So first, the importance is given to the objects. And here the concept break down a programming task into objects that expose behavior or methods and data or members or features or we call attributes of the object using interfaces. And now we will see the features of object-oriented programming. So first and foremost important concept in object-oriented programming is class. And here a class is just a template or a design which contains the various attributes and functions of an object of the class. And here is given an example of a class of cars under which we have a number of cars in the market like Santrosing, Mercedes-Benz, Alto, Wagoner, and so on, which represent individual objects. Now we can design the properties of the car class in common, which will be applicable to all the individual objects. And here are the properties like model, year of manufacture, color, top speed, engine power, etc. And we can also design the functions like start, move, stop, which form the methods of the car class. And the second feature is objects. So an object is an instance of a class which can also be considered as the runtime entity of a class. And objects can be identified by its unique name, where objects can be more than one instance for a particular class. Each instance of the object can hold its own relevant individual data. An object is a collection of data members and associated methods, that is, member functions, which are also binded inside the class. And here is an example given for an object called Alto, which belongs to the car class. And here the properties or the features like model, year of manufacture, color, top speed, engine power, all will be applicable to this individual object Alto. And the functions like start, move, stop also will be applicable to the object Alto, which belongs to the class car. And the next concept we are going to see is encapsulation. So encapsulation means combining both data and function that operates on that data which into a single unit called class. So here the objects which with data and function are binded here where the data is getting protected inside the class concept. So any C++ program or Java program where you implement a class with public and private members can be given as an example of data encapsulation and data abstraction. It means here the abstraction is given like it means hiding complex details of creation, and it just implementation will be hidden without bothering how they work. Like data hiding means to make the data invisible to external functions to minimize the accidental modification or change of important data. So here the implementation details are hidden and the necessary data alone will be open to the users. And the next concept here in object-oriented programming is inheritance. Inheritance is the process of forming a new class from an existing class or the base class. Here the base class is called as a superclass or the parent class, and the new class can be called as a child class or the subclass or the derived class. So the derived class here inherits the properties from the base class. So inheritance helps in reducing the overall code size of the program, which is an important concept here in object-oriented programming, thus having the reusability factor. And the next important concept is polymorphism. Here in polymorphism, it means the code will have multiple forms. That is, the objects may behave differently in different contexts. There are two types of polymorphism. One is compile-time polymorphism or static binding, and the next is runtime polymorphism or dynamic binding. Binding means the linking of procedure call to the code to be executed in response to the function call. When a function call is made, the procedure or the functional code will be linked to the called function. So this process is called binding. And there are two types of binding, namely static binding, which is called as compile-time polymorphism, and dynamic binding, which is also called as runtime polymorphism. So first we'll see static binding, that is during compile time, when the linking of procedure call is done to the code, then this is called static binding or compile time polymorphism. And the dynamic binding means the linking of procedural call to the code to be executed in response to the function call at runtime. Then it is called runtime polymorphism or dynamic binding. And this dynamic binding is also called dynamic method dispatch, which is a process in which a call to an overridden method is resolved at runtime rather than compile time. And the next concept is message passing. Message for an object means we request for execution of the procedure, and therefore we invoke a procedure in the receiving object which generates the desired result. In this concept, the process of programming involves creating a class for defining objects and their behaviors, and then establish communication among the objects through this message passing. So this message passing can be implemented in the form object name dot message, and arguments will be the information to be passed. So for example, when we have a class called employee, we can create an object for employee class, say E. And using that object E, we can call the function, namely the function say get data. So we can use the object name to call the function get data. And the argument will be the information we are going to pass, namely the employee ID, which is passed as 101, and the employee name, which is passed as John. So we can call the function using the particular object, denoting that the data employee ID 101 and the employee name John is, is the data of the object E. So this is how message passing is getting implemented. And next concept we'll see about persistence. That is, the object will outlive the program execution. So we can store the output of the program or the program execution details using file concept. And in C++ and Java, we have this persistence concept which can be achieved using the files. And the next is genericity. It is a technique for defining software components that have more than one interpretation, which depends on the data type of parameters. So here, the generic programming concept can be implemented using the template concept. And here, extensibility, it is a feature which allows the extension of the functionality of the existing software components. So we can update the product and we could go for the next version of our product. And now we will see what are the features of Java, or we can also call those as Java buzzwords. So the first feature we will see now is about the feature called simple. So Java language is simple because the syntax is based on C++. So the programmers, those who have learned C and C++, it will be easy for them to learn Java. And Java language removes many confusing or rarely used features like pointer concept, operator overloading, all those are not there in Java language. And no need to remove the unreferenced objects here in Java because we have automatic garbage collection in Java where the objects will get deleted so at like when it is not in use. And the next feature in Java is object-oriented feature. So object-oriented means like we already saw some of the concepts in object-oriented programming. So all the concepts will be applicable in Java except few. So object-oriented concept here which are supported are object, class, inheritance, polymorphism, abstraction, encapsulation, message passing, etc. So Java here is also a secure language because there is no explicit pointer concept here and the programs run inside this Java virtual machine has a virtual machine sandbox. Hence, the code is getting protected and secure. And the next feature in Java is portable. Whenever the Java code is compiled, the compiler generates a bytecode. And now the bytecode that are generated are safe and you can run on any machine that has the Java virtual machine. Because Java virtual machine is responsible to convert the Java code into bytecode. So if any machine has the Java virtual machine, then you can run the code anywhere. And the bytecode is the key that makes the Java language more secure and portable. And the next feature is platform independent. So Java compiled code can run on all operating systems and a program is written in a language that is human readable language, which is high level language, and it may contain words, phrases, etc., which the machine cannot understand because machine can understand only bytes, that is machine readable language. So here it has two components, namely Java code, which can run on multiple platforms, that is Windows, Linux, Sun, Solaris, Macintosh OS, etc. And Java code is compiled by the compiler and converted into bytecode. And here the bytecode is a platform independent code because it can run on any platform where the Java virtual machine is installed. So we can say that it is write once and run anywhere code. And the next feature is interpreted. So Java interpreter can execute Java bytecodes directly on any machine to which the interpreter has been ported. So the bytecodes here are interpreted from the high-level language and which are translated to machine code by the just-in-time compiler. So the high-level language is interpreted to bytecodes and the bytecodes are translated into machine code. And the next feature here in Java is high performance. The bytecodes can be translated on the fly at runtime into machine code for the particular CPU where the application is running. And now, however, the just-in-time compilers have become so good, that is, they are competitive with the traditional compilers what we have so far, and even they outperform them because they have more information available. So the just-in-time compiler can monitor which code is executed frequently and optimize just that code for speed and just increases the speed of the JVM. So this just-in-time compiler, when embedded in JVM, will increase the speed, the performance speed of the Java code. And next feature is robust. So Java is intended for writing programs that must be reliable in a variety of ways. And Java puts a lot of emphasis on early checking for possible problems and it has runtime dynamic, that is runtime checking and eliminating situations that are error prone. So we have a Java debugger which can dynamically check the runtime errors. The single biggest difference between Java and C or C++ is that Java has a pointer model which eliminates the possibility of overwriting memory and corrupting data. So in Java, there is no need of pointers to access strings, arrays, objects, and even files. Instead, one can use the pointers for the linked list. And you always have complete safety here because you can never access a bad pointer, make memory allocation errors is not possible, or have to protect against memory leaking also. So here we have the best debugger in Java, which can easily sort out the compile time and the runtime errors. And the next feature here is multi-threaded concept. The benefits of multi-threading are better interactive responsiveness and real-time behavior. And here the thread means any program in execution. And multi-threading means multiple programs in execution. So threads in Java can also take advantage of multi-processor systems. So many systems are running at a time. Many processes are happening at a time if the base operating system does. On the downside, their thread implementation on the major platforms differ widely, and Java makes no effort to be platform independent in this regard. Only the code for calling multi-threading remains the same across missions. And Java offloads the implementation of multi-threading to the underlying operating system or a thread library. Nonetheless, the ease of multi-threading is one of the main reasons why Java is such an appealing language or a server-side development is done. So we can run a number of processes at a time and you can switch from one thread to another thread easily in Java. And the next feature here is dynamic. Java is a more dynamic language than C or C++, and it was designed to adapt to an evolving environment where the libraries can freely add new methods and instance variables without any effect on their clients. And Java platform can analyze objects at runtime such as Java graphical user interface builders, smart debuggers, pluggable components, and object databases. And the next feature here is architecture neutral, which the compiler generates the compiled code is executable on many processors irrespective of the platforms. With here, the Java runtime system supports if the Java virtual machine is installed in the platform. And the Java compiler does this by generating bytecode instructions which have nothing to do with a particular computer architecture. Rather, they are designed to be both easy to interpret on any machine and easily translated into native machine code on the fly. And now we will see how the Java environment is, what it consists of. And Java environment includes a large number of development tools and hundreds of classes and methods. The development tools are part of the system which are known as Java Development Kit, also known as Application Programming Interface. The Java Development Kit JDK consists of a number of classes or number of library files, and some of the files have been listed here. So first and foremost is Java, Java C. So Java is Java interpreter. So Java interpreter which runs applets and applications by reading and interpreting bytecode files. And Java compiler is responsible for translating the Java source code to bytecode files that the interpreter can understand. And the third tool is Javadoc for creating HTML documents where the HTML format documentation is created from Java source code files. And Java H which are mainly for producing header files for use with native methods. And next is JDB, that is Java Debugger. So Java Debugger, which helps us to find errors in our programs. And next is Applet Viewer, which enable us to run Java applets without actually using a Java compatible browser. So this applet viewer we can even use for designing web pages. So these are some of the classes or library files which are available in Java Development Kit. And now we will see about application programming interface through which the user interacts with the backend, right? So Java Standard Library or API includes hundreds of classes and methods which are grouped into several functional packages. Most commonly used packages are language support package, that is a collection of classes and methods required for implementing basic features of Java. And next is utility package, a collection of classes to provide utility functions such as date and time functions, and even for getting the input for the Java source code. Okay, so the utility functions can be included here in the utility package. And now we will see the working of Java program. So first we will open a notepad, that is text editor file, where you can type your Java source code. So the Java source code have to be saved as the file name .java. The file name should be as same as the class name where you have placed your main function. So always the main function denotes the execution of the program. So the main function will be placed inside a class. Since the Java is a secure language, we bind all the functions and data into a single unit called class, right? So here the main function also is placed inside a class. So the class name should be same as the file name where you type your source code. So now in the text editor, we type the source code and save it as the file name .java. And now in the command prompt, we can compile the program using the javac tool. So the code here is javac file name .java. So once you compile it successfully without any errors, you will get a class file, that is bytecode file, generated automatically in the same folder where you have saved your source code. So this dot class file then next will be considered for interpreting, that is for executing the Java program. So Java virtual machine will take the responsibility of executing the program. When you execute the program, the runtime errors will be checked. If there are no runtime errors, then you can get the output. So this Java virtual machine you can just install in any OS platform, that is Windows or Linux or Macintosh. So that is why we are saying that Java is platform independent, since you are converting the source code in high level language to bytecode, and this bytecode is common, that is machine readable language. So this bytecode is common and it is given to the Java virtual machine. And now we will see the basic structure of Java program. So the first and section here is documentation section, which improve the readability of the program code. So this documentation section where you mention the details about the program, who is the author and what version you are using or any input sources we are using. So we can just document it in the Java program. And the next section is package statement, which is used to organize the program code. And next, import statement to import the package. So package in the sense the header file what you're going to use. The package can be a predefined or user defined. So you whatever header file, whatever functions you are using, the related package you can import. And next section is interface statement. So interfaces are used to implement the multiple inheritance concept in Java. So multiple inheritance concept is achieved using interface concept in Java. So, and the next section will be class definition section, which is used to define the classes in the program. And at last, the class with main method. So the public classes with main method should be given. And here the main method and the enclosed class. So that is the mandatory one, essential one, without which we cannot execute a program. And the other sections here are optional and the documentation section is suggested. So that in future, if you want to do any updations in your program, this documentation section will be useful for the authors to make changes in the program. And now we will see the example program based on which we can see the explanation for each and every component here. So first we will see the class in which the main function is enclosed. So here the class name is test. So how to declare a class? Class is the keyword followed by the class name. So next is main function. How to declare the main function? Using the keywords public, static, void, main. And here the public keyword is an access specifier which represents the visibility. That is, the main function can be visible to all the objects and even outside the class. So next to the static keyword, any method declared as static is also called as static member of the class. The core advantage of static method is that there is no need to create object to invoke the static method. Once the program is getting executed, the main method is executed by the JVM. It doesn't require creating object to invoke the main method. So the main method will be automatically called once we run the program. So next is void, which denotes that the return type is null. So we do not have any returning value from the main function. And the next, the function name main, which represents the startup of the program. So which denotes the program execution starts from this point. And in the argument in the main function, we have string arguments. So which are called as command line arguments. So when you run your program, at that point, you can give the inputs for the program. So those inputs are collected here as the command line arguments. So here, the arguments in the main function are the array of string data. And now in the main function, we have given a simple statement to display hello Java. So for that, we are using a function println, system.out.println. So here system is the class, that is, and out is the subclass, and println is the function. So println means it will print whatever given inside this function, and after that it will go to the next line. And the text to be displayed in the output here we have given as hello Java. And now how to compile this program and how to run this program. And we know the class name what we had in the program is test. So we have to save this file as test.java. And how to compile this? We have to use the Javac Java compiler, that is Javac space filename.java. And what is the file name? Test. So Javac test.java. So when there are no syntax errors, then we'll have successfully compiled the program. And after successful compilation, we have to execute the program using the syntax Java file name. And here .java extension is not required. So in here in the command prompt, we have to give Java space file name. And now what is the output? So when you compile it successfully, it will go to the next line where you have to give the execution command. So execution command is Java file name. Once the successful execution is done, we get the output as hello Java. And thank you students. We will meet in the next video lecture.